Hey everyone, welcome back to another video from 197 Concepts. In this video, I'm going to tell you how you're going to evaluate or execute the logical operations using the 8051 microcontroller. So this is similar with the operations that are carried out using the 8051, the arithmetic operations. So you can check out that video also if you want to know the arithmetic operations, how those are executed, how to check the output of arithmetic operations using 8051 via the Keil software. So let us start the video. Yeah, this is the calculations of the previous one. These will be useful. And let me just get a blank paper like this section. So what is my idea is, see, for the introduction of 8051, the difference between 8086 and 8051, the starting process of all the things are told in the arithmetic operations video. You can check out that video also. I will leave a link in the description below. And in this video, I'm going to tell you how to carry out the basic three logical operations, which are nothing but logical AND, logical OR, and then the logical XOR. I'm going to tell you with the help of examples. So the basic idea is take the register R0, move it with some data like 06, take the register R1 and move it with some data like 03, and you are going to operate the AND function, then the OR function, and then the XOR function. Okay. Now, if we go for the rough calculation, 06 is represented by, let us say, the theoretical calculation. So 06 is represented with 00000110 binary code, and 03 is represented as 00000011. Now, if you're going to do the AND operation of this, so 0 and 1 is 0, 1 is 1, no carry. So this is here we are not doing the addition or subtraction. We are going to do the logical AND. 1 and 0 is 0, and all others you will get an output of 0. So finally, this is what we call the output is 2. Okay, and operation output is 2. Okay, now the next operation is XOR. For that, I'm going to write the values again: 06, 03. So again 00000110, and this one is 00000011. So OR operation, you must be familiar with the truth table of OR. So for the truth table of OR, if if any of the input is logic 1, the output is 1. Whereas for AND operation, this is the AND operation. If both the inputs are logic 1, only then the output is logic 1. So we are doing OR here. So the output should be 1 if any of the inputs are 1. So 0 or 1, 1, 1 or 1, 1, 1 or 0, 1. So since this is 0, all will become 0. This will give you the output 0. 4 plus 2 plus 1, that is 6 plus 2, that is 7. This is the output of OR. Okay. And the output of finally the output of XOR. Again, for that, 0603 is 00000110. Then next 00000011. So for XOR truth table, the output is 1 if your input combinations are of opposite type. So for example, if you are having both the inputs at logic 0 or both the inputs at logic 1, the output is definitely 0. If any one of the input is opposite to the other, only then your logic will be 1. So XOR 0 and 1 will give 1, XOR of 1 and 1 will give 0, XOR of 1 and 0 will give 1. So again 0, and all these will be 0. So again, this combination will give you the output of 0, 4 plus 1, that is 5. This is the XOR output. Now this has to be verified into the Keil software. So I've already opened the software. I'm just going for project, new project. Okay, I have to go for the on the desktop. I'm going to create a new one, 8051 logical. That's a problem. So renaming problem in the system, no problem. 8051 logical. So that's a project name. I've created a new project. I'm selecting the device 8 HTML 89C51. So this is that. Click on OK. No. Then expand this. Source code, right click, option. Not this one. Not the options. Add new item. ASM file. Again 8051 space logical script file. And here I'm going to type the program. So the very first thing is org 0000h. Then, yeah, of course, I need the end statement. Okay, so just it's a precaution of doing it. Now, from here on, you have to move r0 comma hash 06h. Then, oh, it's O, not 0. Then next, move r1 comma hash 03h. Now here it's logical, and in this case and oh, it's not just and, it's ANL logical and A ANL. That means you have to do the AND operation, which is denoted by AN, but it's logical and. So that's it, ANL. Now let us try this one, R0 and R1. Let us do that. Yeah, I need to move the result in R2, R2 comma 8. Then logical or ORL or logical or R0 comma R1. Again, I need to move this in the register R3 comma 8. Finally, XOR. Okay, logical XOR XRL XOR between R0 comma R2, not R2, R1. Now move R4 comma A. So let us check the syntax if there are any syntax errors by building the target. Yeah, I expected this one because invalid register. All the logical operations are not operatable on these registers. So that's why I'm just moving these from A, R0 and R1 to A and B. That's R0, that's R1, and that's R2. This will be A comma B. This will be A comma B. So just no errors. Then we have to debug it. Stop debug session. Okay. So checking the output, observe the output here in the register tab, and you have to press the key F11. So basically, I'm moving. Oh, it's a problem here. I believe I can do this. Let us check this once. So I'm going to move 06 value into the register A and load register B with 03 value. Yeah, that's not possible. Again, I have to stop the debug session. I have made a mistake here. So it was moving both in A register instead of the. So this is correct here. Let me start the debug session again. Let us see. Okay. So I've corrected here and it was corrected there. but let us see now. A is loaded with 06. Again, A is loaded with 03 because I think I know the problem here. I might be not, I'm not building the target. That might be the problem. So again, I have built the target. Now debug, start and stop debug session. Okay. Now 06. Yeah. So I was not building the target. So building the target is nothing but creating a hexadecimal file, not hexadecimal file, a binary language for your system processor to understand it. Now we have observed here the AND operation of 0 and 6 will give you the output of 0, 2. Let us check that. Where is the flamer? Yeah, 02. Very blunder mistake here. I have moved this into R naught. The result of accumulator register has moved to R naught. Now I've done the logical OR operation for the values that were stored once stored in accumulator register at 06. Now that value has changed to 03. Now this 02 is going to operate a logical OR operation with 02. Based on that, your values are going to change. So let's do the calculation once again. So see here, what I'm going to do is 02, 03, then 00000010 and 00000011. So since this is logical OR, it's 11000000. So accumulator register is going to be 03. Let's check that out. Yeah, that's 0, and I'm going to do the OR operation. Observe the accumulator A register value, it's 03. This 03 is going to be shifted into the R1. Now, XOR operation is being carried out between 03 and 03. Since these two values are same, you're going to get 00000011. Same for A and B. All the 8 bits will be same. That's why the accumulator register is going to be 0. Now, if I move this, you won't be able to see any difference in R2 right now and after executing this thing. Okay. So that's how you're going to check the logical OR operations, or you're going to carry out the logical OR operations, and how you're going to check. That's how you're going to check the registers output values. So that's it in this video. Let's meet in another video. Thank you.